and talk about it. My name is Don Bowman. I think a lot of you know me, but not everybody. So, and please feel free to continue eating Bart's pizza and drinking Bart's beer. There's also a bottle of Grand Marnier if for some reason that needs to come out and somebody else has it. I'm okay with that. So we had some good talking earlier around the topic, the generic topic of microservices, and generally cloud. And so the interesting thing is, when we did this talk at the Duke, first of all, it was in a bar, so there was a lot more sort of milling around and bar talk. But also the interesting thing was, it meant something very different to everybody in the audience. And some people were like talking about very detailed level things, and other people were like, is cloud that thing that they talk about that runs on Amazon, where the Twitter runs, like, you know, the Twitter? And yeah, so it was interesting for me. So what I thought I would do is I would share tonight is some of the stuff that I've learned about do, learn, teach, that cycle. You know, I've gone out and had to meet some people and explain things to them, and that's in turn educated my thinking around it. And one of the things that's a big black box for people is how the plumbing all works in the cloud. They get their head around it, and they got a data center, and they know they got like 3 VLANs, and there's a router between the VLANs, and there's something going between that, and there's a firewall. But as soon as you start to talk about, there's a bunch of elastic things running in somebody else's data centers, and every once in a while, they get migrated for reasons, and what happens? Where does the traffic go? So I thought I'd talk about that a bit. Again, yell at me if you think I'm wrong, or right if you want. So one of the things that I found really interesting is there's different reasons people switch to cloud. And the reason I talk about cloud first is there's this cycle that's reinforcing itself. There's agile, there's continuous, there's cloud, there's microservices. And what they're all doing is they're making things smaller and smaller and smaller so that they scale horizontally, but they're also releasable independently. And it's around small batch sizes, it's around, you know, there's a big cycle that's going on there. You know, we saw it starting maybe 10 years ago or so with apps, where people they went from having an upgrade to Microsoft Office every second year to, my God, there hasn't been an app updated on my Android in the last 10 minutes, the network must be down. We went through that sort of cycle time. And then you start to see that going in through SaaS. And people start to say, well, I'm using a SaaS product, Dropbox, Salesforce, Gmail, whatever. Why hasn't it updated today? It should be better. It gets better every day. And the way they did that underneath it was by making it lower risk to deploy new stuff, by making users accept more risk of things breaking. Like, we used to be very mad when we ran into a software bug, and now we're like, let's Google, the whole company's in beta. But the interesting thing is when you talk to companies that feel that they have professional jobs to run, like a bank, and you talk to them and say, well, why are you thinking about moving to the cloud? And because your next statement is going to be about microservices and plumbing and so on, they come back with 2 different phrases. The first one is they say, it's efficiency. I'm going to save 17% of cash by not owning air conditioning and batteries and servers. And there's another group, which are the smart group, which say, it's about agility. There's something I've never been able to do, and now I'll be able to do that. And what ends up happening is the agile group, they go down the path of disrupt, and they say, we'll blow the world up and start over. And the efficiency group says, I want everything to stay exactly like it is right now. Just be over there, please. I want everything to be on its own VLAN with its own subnet. I can do pen testing, and I want physical access control to the facility. And then that really then constrains how they see the rest of the universe. So when you start talking about things like Kubernetes and microservices, their eyes go blank because they can't get their head around it not being this way it is right now. So that's something I found was really interesting, is that, you know, when you're going down the cost savings path.
I was thinking about doing things easier, relating to serverless. Where that fits in the efficiency?
Well, my friend, let's talk about serverless. There it is. So there's a continuum. Thank you for the segue. I appreciate that. So cloud means something different to different people. To some people, cloud means vSphere. I have 9 servers in my office and they run 12 things. I got cloud. And some people, it's like managed cloud. Well, IBM bought all my servers and they leased them back to me. I got cloud. I don't know where they are anymore. Those I don't think are any more efficient. I think they're minor efficiency improvements there. You just start getting efficient once you start getting into virtual private cloud. So virtual private cloud, what that means is I manage a set of virtual machines on somebody else's infrastructure, and then I in turn then parcel that out. And that's what most of us are probably doing with things like Kubernetes today. And then you get into full public cloud, and then in full public cloud, well, it's just a bunch of VMs that are out there. There's really no infrastructure floating around it. And then you start to get this aha moment about cloud native. And cloud native is where microservices kick in, and you say, oh, if I design things this way, then I don't have to worry. There's no more upgrades. There's an entire chapter in my procedure guide around patch management, and I just deleted that. I don't do any more patch management. Why would I bother? I'm just going to deploy a new container. The old one is gone. It's a read-only file system. There's no thing, like you don't run apt-get update in cloud native. And everything scales horizontally. Now you're no longer worried about how big the machines are. They're all different sizes and they take over. And that's where you start to really get this power curve of efficiency, in my opinion. So just moving your data set to somebody else's data center and calling it a day, I don't think it's worth doing. I think I would keep it on site and keep the batteries. But if you're going to get all the way down here, and that's where you start to get into the interesting / danger zone. So the new hotness today is serverless. Everybody heard of serverless? In a nutshell, serverless means I don't even have any infrastructure. I just run something and it runs somewhere. It's not serverless. There's a server underneath that. But some people talk about it as cloud functions, or you take a function, you run it somebody else's infrastructure. But then you get this warning zone. And what happens is you're drunk on the power of making things smaller. And now you get into what are called nanoservices. We can take this one thing which does this one really well-defined thing perfectly, and we can split it into 10 little things that will never work, and it's really shitty. Because that's nanoservices, right? So what ends up happening is you get, if you go too far, there's no right answer for where too far is, but that's what happens, is you suddenly start to break apart something that there's really no reason for. It's doing its job, it does one thing, it scales on a single factor. This manages the user profile. Well, we've got some users that are tall and short. Let's have a short people profile and tall. Let's do them in different languages. We'll do them in Rust, and that's crazy. So I think it's a spectrum and a continuum, and I don't think everybody goes from left to right. Some people sort of parachute into the middle and move to the right. I think a lot of people think that they can start at the far right and be good, and I think those people are deluded. Because what will happen is they don't really understand. So cloud native is a whole lot of mindset shifts. And you can't get there by telling yourself, I need to get there. You can only get there by sweating it up along here. So, funny story, our wiki committed suicide the other day, and it taught me a lot about how I view cloud native and microservices, and some of those things are now fixed in. So I think it's a spectrum. So nearly no one I have talked to understands the right half of this. So when you talk to mainstream business today, mainstream business sees cloud as either virtual, private, or managed. That's really all they see. Or sometimes it's just SaaS. They see Office 365 as cloud. Then you start getting into other things. So platform as a service. And you start saying, well, okay, now that I'm splitting into microservices, I'm going to have a team that's good at managing my database. So the database is going to be maybe even platform as a service. I'll just rent database capacity, so BigQuery, and there's a bunch of them out there. And then you build on top of that. Now what you're doing is you're either deciding, this was something I was never very good at, and I'm willing to just put a bunch of OpEx into fixing that problem. Or what I kind of feel is you're taking a bunch of stuff that you need to know and you're outsourcing it to someone else, and you're racing to the bottom. Eventually your company will have no expertise in it. So you have to watch out. What you define as outside your set of core competence, it may seem like a good short-term thing, but in the long term you need that in-house to, because you're going to eventually need to tune it. Because in 1 month you're going to wake up and your bill for that cloud database is going to be so big your business doesn't run. And then you don't have anyone left who's a DBA to fix it. So anyway, I think this is really a state of mind. So I'm going to try to coin a new phrase. We've all heard of pets versus cattle, right? The idea. I think it's a terrible analogy. How do you feel about hay versus houseplants? Field of hay, you're going to harvest it. Houseplant, you're going to pet it. Could be a thing. Hay versus houseplants.
Hay can explode if you're not careful with it.
That's chaff from straw. Hay never explodes. Hay will catch fire.
Well then,
I grew up on a farm. Do not tell me about hay.
So the problem is the farm boys understand that analogy. No one else does.
I got one house. But the big thing about cloud that microservices is driving is it's elastic, and that's actually what's interesting. Is if your business can go up and down, and you don't really care about that. You don't sit and worry about, there's going to be a glut of something. And it's really buzzword heavy. So there's a lot of them. So the cloud revolution is really sort of changing my life. There's all these things that are interrelated with each other. So who in the audience uses some form of agile management, right? So pretty much probably everyone here, right? Who's using some form of continuous integration? So probably nearly everyone. Probably not as many doing continuous deployment. So continuous deployment it's tough. But once you get there, you're further down the path. Infrastructure as code is another big buzzword right now. Git is another thing that's driven this cycle. Git as a bit of a revolution. Now nobody even thinks remember what were those crappy open source sites that used to be there, like SourceForge. Oh my God, that was terrible. And only now you see how terrible that was. You're like, oh my God, this package hasn't been updated since SourceForge days. I'm not downloading that. It's a tar zip file somewhere. You expect to be able to just do a pull request. And that's also the open source thing. It's all pulling each other. So when you get to microservices, you can get one small thing that can be released, that can be open source, that can be put on Git, that you deploy from Git as you're doing Git pulls, that you do continuous deployment on, and there it is. And that creates smaller teams and more atomic value delivery, which is what Agile is all around, which is that's the virtuous circle that's there. And that leads to some interesting things. We're going to talk a little bit, everybody familiar with Conways law? Your software mirrors the organization structure that you have. So if you have 2 teams and you make a compiler, you get a 2-pass compiler. If you have 4 teams, you have a 4-pass compiler. Microservices has been around for a long time. So back in the day, in the late 80s, early 90s, there's this thing called service-oriented architecture. And everybody thought this was the big thing. And it came and it was terrible. And it was terrible for a bunch of reasons. But the reality is some of the technology wasn't there yet. But they also implemented it as effectively as monoliths. They would put one giant Java virtual machine up, and they put a bunch of threads in it and call it an SOA. And then a bunch of consultants would move into your office and then charge you billable hours for the next 100 years until you were broke. That's what SOA was. And that's what your airline reservation and your bank are based on today, because they were so sick of that they never made any changes afterwards. And that's why your bank webpage looks like it's a fax copy of a carbon form from the 30s. That's why it looks that way, because they don't want to port it off the 3270 emulator they're on. It's on that SOA. But SOA became good once we started catching up on orchestration and containers and cloud and all the other things that supported. It became around horizontal scale. So once we stopped worrying about how fast one thing could go and started worrying about how we could make 1,000 things go, but the really important thing is around people. Making a machine go faster is interesting because I only pay $1,000, $2,000 for a machine. I'm paying a lot more for my people. So suddenly, I've got a bunch of small teams that can work independently of each other and deliver their own thing with good APIs between them. So there's a bunch of waste associated with that we didn't have in the days of the monolith, but the net sum is more efficient. So yes, it's more efficient to have one big team work on one perfect set of requirements in a waterfall, and day 1 you define everything, and day 2 you build it all, and day 3 you test it, and day 4 you ship it. It's more efficient if you never make a mistake and nothing ever changes. Unfortunately, that never has happened in history. So when you go down to microservices, and you've got 10 teams and each owns their own microservice, they each release as fast as they can without worrying about their neighbors. And I think that's really what microservices is about for me. The rest of it is just technology, and it's going to be gone tomorrow. Tomorrow we're going to be talking about how crappy GitHub and Kubernetes is. Those are the terrible shit things from years ago. That's what we're going to be talking about. One of the things that I found with microservices, so you guys are all familiar with Gene Amdahl. Gene Amdahl, one of the guys that invented the mainframe, parallel computing, and he made this observation. And the interesting thing is if you take your last name and put the word law after it, people assume that you've done the math and that's true. So Amdahl's law basically says there's a limit to how much you can make any job parallel. And what ends up happening is you get to this limit where things spend more time talking to each other, east-west, than they do talking to the thing that they're doing, north-south. So if you have an inherent parallelism in your system, so you think about some big consumer product today, Google search. There's 2 billion people typing something in the search engine right now, and there's not a lot of correlation between those. They can split those up and do them in parallel. But some work doesn't work that way. But then, if they were to then hand that off to 9 things, and they hand it off to 9, they hand it off to 9, the sum total of all the interconnect time would dwarf the amount of compute that was used. And that's one of the problems with microservices. If you go to those nanoservice model, you have too much overhead and latency, and so you can't make it very fast. And then you get very sad because you try to make it go faster by making more, and that makes it worse. So then you go to vertical scale and you say, well, let's make less, make it faster, but your architecture doesn't lead itself to that. That's the worry there. So this is one of the things to be concerned about in a microservices world is how much time do I spend on the interconnect there. And there's some tooling to help you measure that. One of the things I've been using recently is Istio. Istio, it allows you to sort of get a graph. There's tools like Zipcan and Jaeger, and for every transaction between each thing, it's timestamped on the way in and the way out. You can build a Gantt chart. So from the time they come in the front end to the 9 services, the 12 services, and back, you can get that whole time, and you can sort of start to see if that's something you need to worry about. Because the customers are impatient. Back in the day, you would order something, catalog would come in the mail once a month, you would pick up your phone, you would order it would come to consumers distributing the next 3 months, and you would drive in there and pick it up. You got your thing in 6 months, you were pretty happy. And now you're like, why can't Amazon deliver this tomorrow morning? It's 9 p.m., I'm ordering it now. That's the other aspect of Agile that's driving things this way. Conway's law, actually, I think this is something that we can actually take advantage of. So this is actually controversial. If anyone's ever seen this online, so Conways law in a nutshell, whatever your organization is structured as, your software ends up that way. If you have 2 physical sites and you end up with an architecture that has interconnect that way, if your teams sit in 2 different buildings, 2 different languages, whatever. And it's viewed as a bad thing. But in a microservices world, why not have a set of small distributed teams and then in turn allow them to each own their own thing? It's not that you don't want them to talk to the other teams, but you want that interface to a technical interface and an API rather than a meeting level interface where you have to bitch at each other for whose delivery is going to be on time so you can hit the merge window. That's what you want. And that gives you probably the best way to scale software development. We've all read the mythical man month, right? And what it basically says is a late project gets later when you add more people to it, and there comes a point where adding more people, there's nothing you can do. This is a way to allow you to break that up. So if your technical architecture could be constructed into different pieces, and those pieces have loose coupling, then you can put teams on them that individually run at high speed, and they're able to communicate verbally rather than via very complicated workflows. Then you get an efficiency improvement, and then you get your Agile and your user stories and your board and your this and your that, and that virtual cycle. So suck it, you mono-repo people. Who in the room is a mono-repo person? Now there's one, and mono-repo. Yeah, all right. I don't understand the mono-repo concept, but that's just me. You got to watch out for competing orchestration. So this is one of the other things I would really, orchestration, it doesn't really dawn on you until it dawns on you what it is. So the one I've been using a lot is Kubernetes. Some people use Docker Swarm, OpenStack Heat, Terraform. They're each at somewhat different levels. You can't really compare them. I think you'd be crazy to try to do microservices without an orchestrator. I think you would be absolutely nut bar out there because you're losing all the value of being able to very quickly get to a state and restore it. You're losing the value of having a different production staging environment. You're losing the value of blue-green testing and so on. So I would start with the orchestrator there. But in the early days when we had those traditional SOAs, it was a big giant Java VM, and we used messaging buses like Corba around with each other. And those things were manually, one big server would be manually installed, and there was a team of people whose job was to tune them. Anyone who in the room has tried to tune Java, by the way? -XMSX-XMS-G1GC-string dedupe. The number of options is this long. It is an unbounded set, and if you get it wrong, usually it crashes. Not quickly, long enough that you think you've done a good job. You go home and it crashes. That's my story of Elasticsearch from yesterday, actually. I thought I'd made it a lot faster. Anyway, these things are really at odds with each other, so the problem is we've got legacy code from there. But the other thing is polyglot. So polyglot has become a thing. You can't really fight it, but you end up with, it breaks your teams. You end up with team A says, well, we only use language A, and team B says they only use language B, and then you end up duplicating everything because you got an SDK and the 2 languages can't talk, and then the API needs to be, well, you need to make sure you do the API in Swagger so you don't have to duplicate too much of it, but then you need different tooling. Well, one of them uses a Maven repository, and then uses a Docker repository, and there's an efficiency loss there. And I fear that as a small company, that puts you underwater. When you're a big enough company that you have teams that can do tooling and support. Like a buddy of mine works at Facebook, and they had a conference where they did just their internal development support team, the team that writes tools and supports the development. They brought them all together. There's 12,000 people there. I mean, that's a crazy number of people to build things that don't add value to the end customer. But anyway, polyglot is one of the things that drives that. He's like, well, somebody's got to support the Haskell code. I'm like, yeah, it's a true statement. Microservices, one of the things that I was really interested with microservices is if you do it right, you end up duplicating information. So you end up with a database that's owned by a service and another database that's owned by a service. What's the first thing we all learned in database class 101 was normalize everything, duplicate nothing. You're going to have a table called user and everybody else is going to join to the user based on the either natural ID or a synthetic ID. And that way you'll have referential integrity. You'll never have two of the same user and everything will be perfect. What's the first thing they teach you in microservices school? Well, it's a trick question. There's no microservices school. They just kick you out of school knowing nothing and they put you in a company and they make it dangerous by allowing you to commit to Git with nobody looking. But what you first do is every database has its own table called user. And some of them are going to be different. One of them is going to be hashed, and one of them is going to be all caps, and one's going to be this. And the API is responsible for making that all work. And now that guy owns the problem. He's made that decision. He's got to own it. That API is going to be compatible forever. It's going to be duplicated. But if you don't do that, you end up with one big database, and everything funnels through it, and then you end up with a limit on the number of transactions per second. So by doing this, you've dramatically increased your parallelism. And someday, a new business requirement comes in. Well, we need to support customers who have accents in their name. We got some Swedes. We're going to put double dots over the O's. I hope everybody's UTF-8. And then somebody says, well, what about UTF-16? You know, left to right character sets. What about right to left character sets? We're going to do Hebrew, right? So now they've all got to go and add support in their APIs, do the mapping, and try to do the right thing to display that. And they're going to have a lot. Now you're going to run into a problem. One of those days, one of those things is going to crash. And it's going to end up with two of it, one user here and zero here. I don't know how you fix that. I'll let you know if I ever find out. But anyway, that's going to be a problem. But this has something you have to accept.
I feel like there's a balance.
I feel like there should be a balance.
I wouldn't be surprised if a lot of it is a side effect of Conway's law. Everyone just, team working in isolation doesn't really think that there's a database that serves their purpose perfectly well somewhere else that could scale somehow. And, just an intelligent sharding or something. And so they just do it themselves. And then you just have duplication of information for no good reason.
The other thing it occurs to is due to sort of unforeseeable circumstances. So imagine your Instagram. You and a few buddies have spent literally a few hours building an app to not quite display images on the internet. And then you get bought by Facebook for about $2 billion the next afternoon. There's no way your database is going to have the same subscriber ID, same customer ID that the Facebook wanted. So you couldn't possibly have foresawn that. So you're going to always end up having to do some mapping. It seems like people just accept that and get along with it. But yeah, you can have some internal policy to try to prevent disasters that are somewhat foreseeable, I guess. You can have coding standards, you can have lint, you can have CI that checked for 8-bit clean and 16-bit clean. You could, I don't know, you could do stuff like that. But anyway, it seems to me this is one of the challenges that's out there. Only the microservice accesses the data. There's no ODBC here. Like there's no database that everybody just goes and pokes around in. You've got some service that sits in front of it, and that is responsible for normalizing all the requests, securing it, and making sure the data is proper to integrity. So that was interesting. So let's talk about plumbing now. So for the last 6 months or so, I've been building an application to sell socks for cats. And it's true thing. You can go check out the URL right there. And this is the architecture of the application here on the right. And each blue dot is one to n of something. And the architecture is such that this, there's a bunch of load balancing in the front. Cloud is all around load balancing. Each level makes a decision based on some next hop routing, which some people call sharding. Sometimes it's stateless, sometimes it's stateful, sometimes it's user-based, sometimes it's random. But basically, they're all responsible for making sure the next hop that they pick is up and ready and healthy. So you expose one IP to the world, and a set of load balancers share that in what's called a VIP. They then forward that to something that's called an Egress. Does a little bit of logic like vhost routing, dev and pod and stuff like that. The Egress in turn usually rips off the SSL, forwards to your web front end. Then the web front end turns around and makes a bunch of AJAX calls to the catalog, what products they have to sell, a cart, which products they are selling, the user profile, the billing information, the shipping information, a bunch of stuff like that. And they in turn go to a bunch of databases. And because your Vasper team is all polyglot, everything in here is a different technology. You got MongoDB, and you've got Elastic, and you got Postgres, and you've got NoSQL, and you've got lots of SQL, and you got all kinds of junk in there. And every one of them is logging in a different format, and different health checking, and a size a different way. And the only way you can really know it's working is a request from the top comes in, goes to the bottom, and back. Like, there's really no other way to know it's working. So that's one of the big things that I found interesting about a microservices world is you don't alarm manage it on the same way. In a telecom world, it's what I'm used to. Every one of these things has SMP traps on it, and it monitors everything that could possibly go wrong with it. And if any one of those things happen, it puts its hand up, and an alarm goes red, and a person goes over, and they care, and they feed for it, and they fix it. In a cloud world, it's resilient. That happens, and the guy upstream of you writes the requests left or right. So that guy's kind of sick. I'll just stop talking to him for a bit. The second thing that happens, if they're long-term sick, they just get shot in the head, they start up again. And if it's really an algorithmic issue, then it becomes a people problem. But you notice it because the workflow that comes through is not there. And then you try to correlate logs. And log correlation in a microservices world, it's a BFD. It's a really complicated problem because every one of those things is logging in a different format. How many different time formats does the universe have? It's crazy. There's a standard, ISO 8601. If you take nothing else away from tonight, time goes from big to little, so it sorts. Year, month, day, hour, minute, second, microsecond. It always works. People can put it out to a CSV, they can bring it back in again. You can sort it in Excel. It works around the world. It works in Germany, it works in US, it works in Canada. What is this with the day of the week and then the year? The year is the year of the emperor in Japan. Like, how are you supposed to sort that? Like, this might, yeah, anyway, long story. Log correlation is hard. And then somebody's logging URL, comma, user agent, comma this, with quotes, and other people log it with tabs, and you gotta bring it all together. And you're worried about this URL, I gotta trace it through. How do you do that? That's really complicated. So in this plumbing here, this is a logical view. And this makes it look easy. When you intersect this with a physical view, this is running on a set of what are called nodes. And those nodes are virtual machines. And those virtual machines actually have physical homing. They sit on a physical server somewhere. This particular one that I'm running is running in Toronto and it's running in Montreal. And they are very different topology between them. And they're very different topology hour by hour, and I don't have control of that. I have some control of it. But for the most part, what ends up happening is I come in the morning and Google says, by the way, node A, who's moved over here? And usually I don't know, except for the days that I do know, which is a problem, because my wiki committed suicide. Each bubble is a service, and there's messages that go back and forth between them. And this thing can scale very, very fast and very, very wide. So if I suddenly get something that goes viral, maybe Ellen has a cat on the show with cute socks, and suddenly I'm able to sell 1 billion socks a second. It's going to cost me a bit, but this will just scale up inside Google, inside Azure, and that, I won't worry about that problem. I may worry about the shipping fulfillment and my upstream suppliers of cat socks, which is a big problem. One of the things that's really interesting here, and I'm just starting to understand this, I think Kyle's going to talk a bit more about this. Anyone familiar with the term service mesh? Service mesh, service mesh. So there's a bunch of service meshes out there, and they all use the same words, which makes it hard to compare. Light, small, fast, lean, perfect. So there's traffic, there's Istio, and there's Nginx, and there's so we're using one called Istio. And the neat thing about that is, remember, going back to that, CS 101, they taught you not to hard code stuff in your code, right? You got beat over the head with a ruler for that. Forget all that. They taught you wrong. Hard code it in. So what this front end does, it's just got hard coded in. I'm going to talk to a server called carts. It's not responsible for knowing which carts it's talking to. It's not responsible for knowing how many of them are up. It's not responsible for health checking them. It's not responsible for logging the success of that. Service Mesh does that. It just hard-coded a host name called carts. Service Mesh is going to guarantee there's one or more carts up, and if it needs more carts, it's going to go create more carts. That's what Service Mesh does. Other people use Service Mesh for other things. Visibility in here, I mean, this is a bitch. So the other thing we were all taught is, like, you don't know what's going on in your network, you get a Wireshark, right? Has anyone ever tried to run Wireshark inside Kubernetes? It can be done. I've published a tool on the GitHub that sort of has a way to sneak around the back door. But that's a lot of different machines, and there's overlay networking on overlay networking with proxies. All the IPs are private here, so everything is basically 127.0.0.1 and 127.0.0.1. So making head or tail that capture is useless. And by the time you get all the capturing tools out there, the problem's gone. So the other people use the service mesh and they just log infinity to disk, and then they go look into it later. And then other people use it for security. But this is actually a really interesting part of the plumbing that nobody understands. And going back to that earlier stuff, we're all about scaling wide. We're about having a lot of things that are coming and going all the time. You want to be able to, at any point in time, shoot one of these in the head and not worry that a single transaction is going to get lost. Your answer to that is really only the service mesh. But otherwise, everything would have to have a logic in it to health check and load balance its next hop. And that's written in all those polyglot languages that all your stupid developers pick, so you're not going to be able to use a standard library to do that. And that means you're going to have 10 different implementations and 20 different sets of flows. How does it flow? If you've done your job right, your microservices are going to use very short transactional idempotent stateless protocols. You're not going to want to have a bunch of things that are talking Redis to each other. There's nothing wrong with Redis, but I'm saying things that open a TCP connection and keep it open forever are going to be much harder to scale this way than something that the TCP connection isn't that important. So HTTP is really what this is designed around. All the routing information is in one transaction. It's got the next hop, which is the URI, it's got the host name, and those can be routed independently of them. It's idempotent, means that you can reorder them and not care. You can send them to different hosts and not care. I know a lot of people have written web servers that store stuff in /temp and they use it again for their session store and so on. Won't work. So it's not to say that Redis is wrong, but we're going down a path where everything is a single HTTP message, and how it gets there is irrelevant. It might be SCTP tomorrow, which is what I think would be better than TCP. And hop by hop, everybody's routing, just like layer 3, only not at all like layer 3. But it's like layer 3. There's destination address and everything, and it routes it to one at the end, and you're going to hard code those names. So you're going to see things like HTTP://elastic. Nothing wrong with that. So the surprises that I had, so the first one was Revenge of the NAT. So who thinks that NAT and firewall are the same thing? Anyone in the room think that a NAT's a good firewall? I bet you that all of you, that's the only firewall you have at home is NAT, right? You went and bought D-Link, Linksys, something like that. The only reason that you think it's firewall is because you've got private IPs and no one can get to them. But you've also got V6 in your home, right? Like your vacuum cleaner is V6. And it doesn't NAT bad. So it's not firewall in NAT. So right now, does anyone want to rush home and fix that? Okay. In the cloud, there's 3 levels of network address translation. This was crazy complicated. So going back here, okay, the user who is somewhere on the planet sends us a TCP connection. They got a source IP. I may need that source IP for something. So I might decide either I'm doing analytics, country-based, maybe I'm doing a firewall, geo-IP-based. I'm not allowed to sell mega millions lottery tickets to Canadians who wanted to buy the $1.6 billion thing today. Not speaking to someone at track. Comes in. The first level load balancer, it does a NAT. So now the next level, when it gets to Egress, that's gone. Now I got an IP address which comes from my space to my space. The Egress turns around, and what's the Egress? It's a proxy server. It's Nginx. So now the packets come out of it with its source IP address, and they come to your front end. So now the front end is getting a packet that comes from your Egress controller to your front end. And then, because you use the service mesh, paying attention to people like me, I use a technique called sidecar. It turns around and proxies it again, because more proxies better. And now it's coming from localhost. So now your front end has got a packet that's come from 127.0.0.1 to 127.0.0.1. And then you log it to disk. At the end of the month, something bad's happened. Maybe there's been some money stolen, something like that. The police are at your door, I don't know why. And your auditor's here, and they want to know where to go. And you're like, well, let me look on the logs. Okay, the thief was inside the server. 3 levels of NAT. You're screwed. So that was the first big one for me, is the Revenge of the NAT. If you have any sort of geo-IP restriction policy or something like that, it's a big problem. If you have a ISO 27000 guide that says you have to audit all your sources, it's a big problem. I'm not saying not to do cloud. I'm not saying not to do Kubernetes. I'm just saying you're going to have to be explaining this to some people, because they're going to be surprised. They're going to say, well, we didn't have that problem in the proprietary data center. It's true. Second is, east-west firewalls are harder. This is really interesting. A lot of, who here runs some sort of east-west firewall protection from A to B inside their system? So nobody. All right, one guy. Okay. Who here should be? So this is about what's called defense in depth. Something in your system is weaker than something else. I promise you. Tesla's infrastructure, people were Bitcoin mining on it. They got in through one thing and they went sideways, and they were Bitcoin mining on it. Now, ironically, that's probably the best thing, because all Tesla lost was money. But what if it had maybe made some changes? Maybe it sent all the locations that he's driven to his wife, and now there's a divorce. Maybe it puts the autopilot's car in max mode into something funny, and it becomes UP, and he goes in the trunks of the road. So probably that's the best thing that could happen. But there's a lot of those things are happening every day. They get into the weak thing, and then they go from the weak thing into the strong thing, and then they're screwed. East-west firewalls are really hard, because going back to that topology there, there's no physical, like things are sometimes on the same server, sometimes on different servers, sometimes in different buildings. There's no IP-based things. It's a tough thing. You may have a business policy that says dev and prod can't be able to talk to each other, and you may not be able to make that happen. So again, when you're telling your boss if you're doing microservices and cloud, maybe bring this stuff up front, because you're going to have to change the policy rather than wait till later. This whole concept of the big fat firewall you spend a lot of money on, you put it at the door, it's gone. Like Palo Alto, that's just not there anymore. Supply chain risk, this is one of my favorite ones. Microservices, these are all really juicy pieces of software. Instead of having one big release that's released once a year, you got 10 teams that you're telling them you want to go live with continuous deployment. They're deploying 10 times a week. Not a lot. People are putting stuff out there 10 times a week. And that means that every time they do a build, they run npm install or go get or py. And those things go to their upstream. And those things go to their upstream. And so on and so on. This summer, one of the most popular packages for Node.js, ESLint, was hacked. One of the 4 developers used the same password on 2 sites, didn't use two-factor authentication, and got hacked. So somebody published a new one there. In the 15 minutes it took them to catch that, there were 700,000 people who installed that. Every one of those people, they got access to their node credentials and was able to push stuff into their node repository. And ultimately, sites like BA got hacked and knew it, and you lost your credentials. So there's a supply chain risk. Do you audit all the supply, all the software that comes in from those upstream open source? There's no way, it's just not possible. Even if you did it for the first level, well, I import package A, I've reviewed package A once. But package A imports package B and C. Package C imports package D, E, and F. It's like that thing you did during Frosh Week. They said, shake hands with the person on the left, shake hands with the person on the right, something other about STDs. I don't remember the rest of it was, but it wasn't that good, right? That's what this is all about. And that's why you need defense in depth. You need an east-west firewall, because your microservices, one of them is pulling something bad in, and it's in your Docker repository. It didn't come in through the firewall, you put it in there, and then it went outwards. That's why you need it. Every time something's built, 80% of the building just have some changes. It's crazy. You can pin everything, and then you go to the other end of the spectrum, where now you never get the updates, the CVEs, and you have the vulnerabilities, and there's really no great answer here. So now you're starting to realize that microservices is bringing in a big evil inside, and it's starting inside and working its way out. That was a big thing for me, which led right to this last one. Who runs an egress firewall? Who filters their own traffic in egress? I know that guy's going to do it. None of the rest of you run an egress firewall. So imagine when your boss comes to you and says, geez, I found this USB key in the parking lot, and I plugged it into my laptop, and now I don't know what's happened, but you did make sure that the payroll system didn't post the internet, right? Like, oh, why would the payroll system go to the internet? Oh, everything goes to the internet. Oh, look at that. So that's called covert exfiltration, or sometimes they're connecting what's called a C2, a command and control channel. Now there's a botnet running out of that. So maybe the guy that's in your infrastructure doesn't want to get caught. Maybe they want to be here for a long time. Maybe it's a hedge fund. So maybe you're Tesla and they want to know how many Model 3s you're going to make next month. So yeah, egress firewalls are hard. Some of the things you use are SaaS. So my microservice that I've built, it uses external services. They're not just microservices I built. Auth0, GeoIP, New Relic, the list goes on. And they need to get to the public internet to do that. But let me tell you, you cannot create a layer 3 firewall in egress, because every one of those things is going to do something like chat.google.com, which is the same IP as every other Google service, Gmail and YouTube. And you think you can't get data by posting on YouTube? Salesforce, they're just running that in Amazon. Like what IP are you going to allow or deny? All of Amazon? Like what kind of security policy is that? Anyone with a credit card or a stolen credit card can make a server that I can talk to. Yeah, great policy. This is a really, really complicated problem. Again, I'm not saying not to do microservices. I'm just saying you're either going to have to pick a security strategy that's different, or you're going to have to do some work. Surprise number 5, just to finish up. There's no subnets. So there's a big security team in your company, and they run tools like Nmap and OpenVAS and this and that and the other thing. And how do you configure them? You type in a subnet. What's the subnet for my database server? What's the subnet for my printer? What's the subnet for this? And every month you run it, and a big shiny report comes out, and consultants come in to tell you whether you've done a good or bad job, and you keep your PCI compliance because of that. And now you switch to the cloud, and they're like, well, where do I configure the subnet? And you're like, I don't know. It's just random IPs are different every 2 minutes. No subnets. Think of all the things you're doing there, like mapping, asset discovery, firewall, VPN, auth. The cloud IPs, particularly when you get into public cloud or serverless, like the IP is just a meaningless thing. And then you get IPv6 with the privacy things, it's really hard. So, here's my advice. Feel free to jump out with questions if you disbelieve some of the stuff I'm saying. Don't despair. The new ways are better. So I listed some of the downsides. I listed some of the upsides. On the whole, it's better. Cloud is actually pretty secure. I would feel better about the security of logging into GitHub than I do about logging into my bank. Like, not a word of a lie. I am much more confident that my G Suite is not going to get leaked than my financial information, just because of the way they do things. I think strict lift and shift is a myth, it's a mirage. There's a lot of people that think, okay, I got 9 physical servers, I'll just make 9 virtual machines, we'll give them the same names, we're done, we're cloud, right? I think that's just crazy, I just wouldn't bother. Like, why? Like, you've not achieved anything. Your team's gonna have to learn a lot of these stuff, but you're not getting any of the value. I think people are gonna have to embrace defense in depth. You know, microservices is really complicated to do that for, but you can't have one firewall at the door that all your trust is in, you have to have it all over the place. And I think that as long as you're continuously getting better due to continuous integration, continuous deployment, agile, upgrade often and be good at it. You know, companies that upgrade multiple times a week aren't sitting there worried about, is this upgrade going to break my customer? So when something hits the fan and you need to get an upgrade pushed immediately, you don't sit there and go, oh my God, we're going to blow the universe up. Companies that plan for upgrades that have MOPs, I've been there, it's very, very hard to get it right all the time. Anyone else in the room agree with the MOP upgrade? Anoop? I know you got some sympathy for that. Pick your battles. So, you know, inside the company, there's going to be a bunch of people that are complaining about some of these. IP transparency, east-west firewall, egress. Don't try to do them all at once. So that's the cloud doctrine. So that's mine. And any questions on my lightly opinionated discussion of what I learned about microservices in the last couple of days? Lightly opinionated. All right, we got one up front.
I've seen a headline on YouTube about Netflix work on microservices. It looks like they are most advanced in this area, and they use OAuth for microservices.
Yeah.
And regarding your, you have a slide there with the evil of microservices. Where is that?
So OAuth, so the service mesh, this is something I found interesting. Istio does what's called mutual TLS. I authenticate you, you authenticate me, point-wise for every pair. It's not service to service, it's service instance to service instance. So it means that front end A and cart B know they're talking to each other both directions. So it's probably not OAuth they're using there, or maybe they are, but Google invented their own called, it's a proprietary protocol, but 2 TCP connections, gRPC on one, TCP on the other. But anyway, they've ultimately moving towards the mutual TLS model. Does anyone remember the name of the Google one?
ATLS?
What's that?
Is it ATLS?
Yeah, ATLS, that's it. Netflix is very advanced in microservices, mainly because they're scaled. The people that have scaled that big have generally figured out some aspect of microservices. So Netflix and Google have collaborated on a deployment tool called Spinnaker. And Spinnaker is one of those tools that you're going to need if you're going to get to 10 upgrades a week. You know, it allows you to specify how everything's going to work and so on. There's other tools in Terraform, Kubernetes that are related, but that's another aspect that those guys have to figure out. Another thing that they've got good is a discipline that never used to exist called SRE, Site Reliability Engineer. And the SRE is responsible for a bunch of things that we didn't used to have as disciplines. And then the other one they've gotten good at is red teaming their own team. So Google will periodically, they'll just hold a fire drill and just pull the power cable on the city, and they don't tell everybody else. It's not like tomorrow at 10 we're going to do this, we'll see how it responds. Just do it periodically. So some of these guys, they've had to figure it out, because at that scale you can't be running SNMP alarm checking on each servers, checking for a bad fan. Just there's always
like the Chaos Monkey stuff?
Huh?
Is that like the Chaos Monkey?
Yeah, Chaos Monkey is another one. So, you know, that's fuzzing testing is another example. There's a whole whack of tools. So Google uses these ones called sanitizers, ASAN, TSAN, MSAN, so adder sanitizer. They compile the code differently, and then they muck up the memory, and they look for buffer overflows. They do the Chaos Monkey, a bunch of tools. And then the other thing I would say is, you got to look at the size of the company you're in. It's one thing to say, oh my God, Netflix is doing this, I should be doing that too. My company is slightly smaller than Netflix right now. The number of people I have to allocate to this is less. So I'm not going to get there by doing 1 micron of everything they do. I'm going to do it by doing 3 things really well and leaving some of the others for later. Ian?
One of the other things I've seen to solve some of these problems is instead of having every microservice talk to every microservice and requiring all your firewalls and everything to be able to discriminate against them, is you have some type of message bus or you authenticate the message bus, put messages there, and people that should be able to get those messages can also authenticate to the message bus.
So this was pretty controversial because, yeah, I mean, I think that's going away to be blunt.
Sorry?
I think that's going away to be blunt. Because ultimately those message brokers have to give a guarantee of delivery. It becomes difficult to scale. The same way a relational database, if you have multiple and they have to pass it, it's difficult to do that. Whereas in the store and forward model of the HTTP, where everybody's responsible for getting to the next hop, I think it's easier. I think
it's much harder to have guarantees in that model, because there's something along your
there is no guarantee in this model. However, it's still the overall system is guaranteed, but no hop is guaranteed. That's what they're striving for here.
I think that's very challenging. I don't think they'll be able to do it.
I've never had a cat sock order drop yet. But yeah, that's actually one of the things I've been doing some research on. That is like there are different architectures. The sort of AMQ bus, where everybody forced AMQ and everybody keys out of it, versus the everybody talks to everybody and they have a well-defined guarantee, and those are scaled piecewise. I think they're kind of different. Dave?
You get a chance to hear about why the electronic voting went so badly yesterday?
By the electronic
Voting?
How did the Curelet was formed? How did
Russian hackers?
The official board is ISP problems. The official board was ISP problems. They were throttled. Dominion was throttled. Their own
It seemed like they didn't know how to scale.
It's a great 35% credit.
So go back to the serverless thing we talked about earlier. One thing the serverless is really good at is chaos monkey style load generation. Like if you've got a couple of bucks to spend and you got a web server that you want to test 10,000 users on, that's what serverless is good at. Just get them to go blast you. I don't mean like DDoS style, but like with some behavior. It's actually a pretty easy way to scale that up. I didn't really look into it. Electronic voting is one of those things that is a really great idea, except the implementations are not very good.
Seems like they might have rules that they're not allowed to be in the cloud or something. Which
One of the things I've learned, I've talked to a lot of companies that all believe that they are regulated or ruled in some way that I don't believe is true. They have this sort of group thing. I can't have any of my data outside of Canada. I can't have outside my building. You know, I talked to the Toronto Stock Exchange. They believe that there's something under OSC that prevents this. I looked in the OSC. They're like, yeah, no.
Do they believe that, or is it just their legal team automatically says no?
It is a widely held belief with no individual observable source of truth. Reinforced by people in the hall saying, yeah, the reason we're not in cloud is.
The flip side of that is it's turned around the other way. It's not that the US, it's not said no, that data can't be in Canada. The argument is you can't put that data in the States because once it's there, the US government can look at it and not tell you.
Yep.
That's the argument. So we can't risk that data just being exposed and us not knowing about it.
Can I ask you a
So
question?
it has to stay in Canada.
I know a fair bit about telecom. Does anybody know what percentage of Canada's information flows to the U.S. at some stage of its life cycle? It's nearly 80% because of the geography of the Great Lakes. Nearly all of Canada's internet goes through what's called TOR, Toronto Internet Exchange. And to get anywhere else in Canada, it goes through Chicago, it goes through New York. It's a really interesting problem. So there are countries that are putting like undersea cables directly between Germany and Brazil because of this type of thing, but there's also countries that have submarines that have been observed near this cable. So. Yeah, I'm not saying it's not a real concern or anything. Like I believe in data sovereignty.
It's a concern for the lawyer, and the lawyer's in the room, and the agreement doesn't happen unless the lawyer says so. So that's
one of the things that shocked me. So when I first started, we picked Google Cloud. I picked Montreal. I installed my massive IT infrastructure, and then I got my first cloud bill. And I was paying for bandwidth from Canada to the US, and I did not understand why. It's because they don't run all services in Canada. They don't run a container registry in Canada. They don't run a CI/CD in Canada. So, there is no data sovereignty in cloud is an area of rich professional services engagement for the legal community in the future, I think. Okay, why don't we let Kyle come up and talk for a bit, and then anyone can butt us for our likely shared opinions. There's more pizza and beer there as well.